Hello, good evening, students. Please respond. Am I audible and visible, please? Ping me the audibility and visibility, Qadir. Is everything clear? Okay. Very good, very good. Chalo. Welcome back again to PW platform, GATE crash course, the subject of algorithms. Chalo, very good. We are ready to start today's session. Continuing from divide and conquer where we left off in the last class. ठीक है? लास्ट क्लास में हमने डिवाइड एंड कॉन्कर के बारे में बात कर रहे थे. हमने देखा प्रॉब्लम मिन मैक्स. आज हम देखेंगे मर्ज सॉर्ट बिफोर वी कम टू आवर एक्चुअल टॉपिक, मैट्रिक्स मल्टीप्लिकेशन यूजिंग डिवाइड एंड कॉन्कर. ओके, तो कैसे करेंगे मैट्रिक्स मल्टीप्लिकेशन, डिवाइड एंड कॉन्कर, एंड व्हाट आर द अदर अप्रोचेस आल्सो. उससे पहले हम देखेंगे वन ऑफ द वेरी इंपॉर्टेंट प्रॉब्लम ऑफ डिवाइड एंड कॉन्कर, जिसे हम बोलते हैं मर्ज सॉर्ट. One of the sorting technique, prominent sorting technique, which is essentially based on divide and conquer ideology. So divide and conquer, merge sort. आपने डेटा स्ट्रक्चर्स में भी पढ़ा होगा मर्ज सॉर्ट के बारे में. तो हम यहाँ पर एक नया वर्जन ऑफ मर्ज सॉर्ट पेश नहीं कर रहे हैं. हम यहाँ पर देख नहीं रहे हैं नया वर्जन ऑफ मर्ज सॉर्ट, बट रादर हम देखेंगे कि हाउ मर्ज सॉर्ट इज एसेंशियली इंट्रिंसिकली यूजिंग डिवाइड एंड कॉन्कर. मर्ज सॉर्ट की जो वर्किंग प्रिंसिपल है वो एसेंशियली बेस्ड ऑन डिवाइड एंड कॉन्कर है. वही हम जानना चाहेंगे, वही हम देखना चाहेंगे. अभिषेक बासु 2025 बैच, आई डोंट नो व्हेन विल दे शेड्यूल. अभी तो मेरा 2024 बैच चल रहा है, उसमें एक 2025 बैच भी है. You will have to see the app of PW to get the details of the batches. Frankly speaking, मुझे उतना कुछ आइडिया नहीं है बैचेस का. Okay, so don't ask me that. मुझे पता नहीं है वो. चलिए, I would like to tell you that the working principle, the basic principle on which merge sort work is what is known as, हम बोलते हैं merging process. तो ये merging process हमें पहले understand करना पड़ेगा. So this merging process is actually like your conquer और योर कंबाइन अप्रोच. तो पहले हम ये लर्न करेंगे, फिर उसके बाद देखेंगे कि प्रॉब्लम कब बड़ा होगा तो डिवाइड करेंगे, डिवाइड कैसे करेंगे, क्या है, ऑल पूरा विल हैव ए डिटेल लुक, विल हैव द एल्गोरिथम, विल हैव द परफॉर्मेंस कंपैरिजन, परफॉर्मेंस एनालिसिस आल्सो. हर चीज देखेंगे हम इन डिटेल. प्लीज फॉलो मी केयरफुली. मर्जिंग प्रोसेस वी नीड टू अंडरस्टैंड बिकॉज मुझे अच्छा याद है इन वन ऑफ द अर्लियर पेपर ऑफ गेट देयर वाज ए सिंपल गुड क्वेश्चन आस्क्ड बेस्ड ऑन मर्जिंग प्रोसेस in one of the PYQ. ठीक है. So what is merging essentially? Merging, given two sorted list, let me write, given two sorted list, say L1 and L2, having N1 and N2 number of elements, where we say N1 is less than or equal to N2. ठीक है. It is required to merge both the lists using two-way merging. To get A means one sorted list. ये है मर्जिंग का डेफिनेशन. बहुत इंपॉर्टेंट ऑपरेशन है, जनरली कंप्यूटर साइंस में काफी यूज होता है in many of the problem solving. Given two sorted list L1 and L2 having some number of elements, say N1 and N2, where we say without losing any generality N1 is less than or equal to N2, we need to merge with two-way merging so that we get one sorted list L. Like for example, if I take L1 as having number of elements like 2, 3, 5, 8, L2 having elements like for example 4, 6, 9, 10, 12, 15. तो देखिए यहाँ पर 4 एलिमेंट्स है, यहाँ पर 2, 2, 4, 6 एलिमेंट्स है. N1 is less than or equal to N2. मर्जिंग, टू वे मर्जिंग कैसे होगी? मैं यहाँ पर एक बार sketch बना रहा हूँ, two-way merging. So we are going to merge these two lists to get one single sorted list. These are essential principle of merging that we are going to adopt in the two-way merge sort. So we are going to initialize two indices, two pointers respectively pointing to the first element of both the list I and j. I and j are initialized to point to first element of both the list. अब आप एलिमेंट्स को कंपेयर करोगे, राइट? इंडिसेस को कंपेयर नहीं करोगे, एलिमेंट को, एलिमेंट पॉइंटेड बाय द इंडिसेस. जैसा 2 है, 4 है, so 2 is compared with 4, 2 is small, you copy 2 here in the final sorted list. Advance the index I to point to the next element, then again compare 3 with 4, 3 is small, so copy 3. ठीक है? Then advance the index to point to the next element. 5 and 4, 4 is small, so 4 is copied. Advance the index to point to the next. 5 and 6, 6 is 5 is small, so 5 is copied. So like that, this will continue until one of the list get exhausted. या हमारे पास first list will get exhausted. ठीक है? First list will get exhausted. तो हम क्या करेंगे? Balance elements जो है second list के वो यहाँ पर append कर देंगे. Will append. So this is our final sorted list. Final sorted list. This is called two-way merging. A very prominent simple operation that we use in general computer science problem solving. इस बेसिस पर merging process के ऊपर, merging process के basis पर मेरा एक आपसे एक simple question है. Let me see how many of you can answer. Right? The question is, let me squeeze this. The question I'm putting it here like this. Please follow carefully. What is the time complexity? Right? To merge L1 and L2. Number 1 in the best case and number 2 in the worst case. Best का मतलब invariably I'm asking minimum and worst case मतलब maximum time. Think and tell me. This one among them was a great question for 1 mark. What is the time complexity in the best case or in the worst case in order to merge two list L1 and L2 whose definitions are given here? List L1 having N1 elements, list L2 having N2 elements. To get a single sorted list L, what is the minimum time and maximum time, best case and worst case time needed to merge the two sorted lists? Come on. If you don't want to answer the time complexity, you can even tell me, for example, what is the best case, or if you don't want me to write best case and worst case, maybe I can write it like this also. What is, instead of saying time complexity, देखिए time complexity will depend on what? What is the metric? What is the metric? Metric parameter on which the time complexity of this merging operation depends on. Come on, what is the metric? The metric is comparison, element comparison. Is it not? Time depends on element comparison. The time depends on the element comparisons. How many comparisons are made in merging these two lists? Right? This list L1 has N1 elements, list L2 has N2 elements. We are saying N1 is less than or equal to N2. L1 is less than, N1 is less than or equal to N2. So L1 and L2, when we want to merge, I am asking you what is the minimum number of comparisons first. पहले minimum की बात करेंगे. तो उससे आपका best case आ जाएगा. Minimum number of comparisons. Come on, tell me. Yes. What is the minimum? What is the minimum number of comparisons? N1. Yes. What do you mean by both cases? N1. Question is, when will this happen? When will I get minimum? What kind of data set? What kind of data set for list L1 and L2 will give you minimum number of comparisons? कौन सा मतलब आपका data set क्या होना चाहिए L1 और L2 का, so that I get minimum number of comparisons in merging the two lists to get sorted list? कब होगा वो? Minimum will happen, remember, minimum n1 is correct as most of you said, but question is when will that happen? कब होगा वो? जब होगा when all the elements of L1 are less than, you can say first element, it is as good as saying all elements of L2. This will be the case. When all elements of L1 are smaller than L2, correct. Vandana, you are right. But you made a mistake, small mistake there, check it. All elements, I'm following a notation. Modulo L1 means all element, that is my notation. All elements of L1 are less than first element of L2. It is as good as saying all elements of L2 because first list L2 is sorted in increasing order. So therefore, you can say first element of L2. Like for example, if you take a simple list L1 having elements 2, 3, 5, list L2 having elements for example 6, 8, 10, 12. 2 is compared with 6, copy 2, 3 is compared with 6, copy 2, 5 is compared with 6, copy 2, finish. After that I don't need any comparisons. So therefore remaining elements are simply appended here. So this become my data set for minimum. उसी तरह बता दीजिए मुझे maximum when will it happen? Maximum, what is the value first? Maximum number of comparisons. Maximum number of comparisons will be how much first? I want the exact value please. Exact value चाहिए मुझे. Come on. Maximum की value बता दीजिए मुझे पहले. Maximum की value क्या होगी? Boys and girls, please tell me. Yes. Azan, Amin, you are right. Qadir, I'm not asking order. Order हम बाद में पूछेंगे. Exact value. Satyam B. Naik, I want exact value. Yes, you are right. The exact value will be N1 plus N2 minus 1. N1 plus N2 minus 1. That's exactly correct. अब यहाँ लिख के बता दीजिए, प्लीज लिख के बता दीजिए कि ये कब होगा, फॉर व्हाट काइंड ऑफ डेटा सेट. क्या आप कोई सजेस्ट करोगे डेटा सेट? What kind of data set? For what kind of data set will you get maximum number of comparisons involvement? For what kind of data set? The data set should be L1. My data set ले रहा हूं directly. फिर उसके बाद मैं लिखूंगा list L1 having for example elements like 2, 3, 5 और एक element है 40 and list L2. List L2 has elements for example 8, 10, 12, 15 and this is 18, 20, something like this. That means if you observe N1 minus 1 elements, follow me carefully, N1 minus 1 elements are less than first element of L2. Check it. N1 minus 1 elements of list L1 are less than the first element of L2. So that is going to make N1 minus 1 comparisons. N1 minus 1 comparison बनाएगा वो. फिर उसके बाद क्या होगा? The last element of L1 is greater than all elements of L2. Last element of L1 is greater than all elements of L2. This is one data set. इसी तरह और भी data set हो सकते हैं. There is no problem. I am taking this. All elements of list L2 are greater than, are less than the last element of L2. So that will make plus N2 comparisons. So that's why it become N1 plus N2 minus 1. N1 plus N2 minus 1. Right? So this become the data set for maximum case. So total comparisons are N1 plus N2 minus 1. Right? If I take the order of it, then it become order of N1 plus N2. ये हो जाएगा आपका टाइम कॉम्प्लेक्सिटी जो मैंने पहले पूछा था. अगर आप इसका ऑर्डर ले लेंगे, then it become time depends on number of element comparisons. Number of element comparisons are this. So time complexity to merge two sorted list L1 and L2 having N1 and N2 number of elements is order of N1 plus N2. If you take order of N1 plus N2, if you take, for example, if you say number of elements is N1 plus N2, nothing wrong, you can write this as order of N. As a small note, what I wanted to tell you, what I wanted to write it for your convenience is, in order to merge two sorted lists L1 and L2 having N1 and N2 number of elements. then the number of element comparisons oscillate, means lie between, oscillate between n1 and n1 plus n2 minus 1. Will lie between these two factors. So this is an important conclusion you have to remember as a very important point with regard to merge operation, you can say, or with regard to conquer method that we follow for merge sort. Okay, this is the paradigm, basic paradigm. This is a basic paradigm of merging which is used in merge sort, minimum and maximum number of comparisons. चलिए अब ये basis पर हम attempt करेंगे merge sort. So here I am going to show the principle of divide and conquer which is followed in merge sort. I am taking the sample list. You can take any list as such, there is no worry. Okay, so I am considering the following list A with 10 elements and I want to sort them in increasing order using the principle of merge sort. Because I have to perform the merge operation, so I need another temporary array by name B, equal size of A. A is having n element, B also will have n elements. Temporary array B, where I am going to merge at the respective place where the elements are taken from array A. तो जब भी हम डिवाइड एंड कॉन्कर के बेसिस पर प्रॉब्लम को सॉल्व करेंगे तो फर्स्ट क्वेश्चन जो हमें एड्रेस करना पड़ेगा कि व्हेन शैल वी डिवाइड द प्रॉब्लम इनटू स्मॉलर प्रॉब्लम्स, राइट, एंड व्हेन विल वी कंसीडर द प्रॉब्लम टू बी स्मॉल. क्या आप मुझे लिख के बताएंगे चैट विंडो में, फॉर मर्ज सॉर्ट ए लिस्ट हैविंग हाउ मेनी एलिमेंट्स, प्लीज बॉयज एंड गर्ल्स लिसन टू मी, फॉर मर्ज सॉर्ट ए लिस्ट हैविंग हाउ मेनी एलिमेंट्स विल यू कंसीडर द प्रॉब्लम टू बी स्मॉल? कम ऑन, लिख के बताइए मुझे. List L1 and L2 having how many elements will you consider the problem to be small? Come on. Array has only one element. Means list having one element. Exactly correct. List L1 having one element, list L2 having one element, then it becomes small enough to merge. Why? Because it needs one comparison. The problem is said to be small if it can be solved in one or two basic operation. और यहाँ पर basic operation है element comparison. मतलब एक लिस्ट में एक एलिमेंट हो और एक लिस्ट में एक एलिमेंट हो, हमें एक कंपैरिजन लगेगा उसे मर्ज करने के लिए, राइट. सो देयरफॉर हम मेरी जो लिस्ट है वी शुड कीप ऑन डिवाइडिंग अंटिल इट गेट रिड्यूस डाउन टू अ लिस्ट विथ ओनली वन एलिमेंट. उसके बाद हम बॉटम अप वर्क करेंगे टू गेट ए मर्ज ऑफ ऑल. सो चलिए सेपरेटली मैं डिवाइड प्रोसीजर और मर्ज प्रोसीजर आपको यहां पर बताऊंगा, एन्यूमरेट करूंगा, डिवाइड ट्री एंड मर्ज ट्री बोथ. फिर मैं एल्गोरिथम भी बताऊंगा आपको, डिवाइड प्रोसेस और डिवाइड ट्री. The node of the tree represent the problem instance. Node of the tree represent the problem instance. मैं इस instance के लिए वर्क कर रहा हूं. Either you can solve with indices or you can solve with elements. दो भी procedures है. Different people follow different convention. मैं यहाँ पर indices से follow करूँगा. So lower index of the array is 1, higher index of the array is 10. This is low and this is high. List with 10 elements is large, so we follow equal size division. That means I divide about position 5. Low plus high by 2. The element 5 become the mid element. So I get two sublists, one from 1 to 5, other from 6 to 10. So simultaneously we can check it like this. List has become like this. Original list with 10 elements has been bifurcated into two lists, each having 5 elements, 1 to 5 and 6 to 10. Recursively I take on the left sub problem. List with 5 elements is large, so we should divide. What is the division point? Low plus mid, low plus high by 2. So mid is 3. The division takes place about 3, 4 and 5, right? So that means the division is happening like this. Okay. फिर हम recursively 1 to 3 लेंगे. 1 to 3 is also large because that is list with 3 elements. So we divide about position 2. So division takes as 1, 2 and 3, 3. Like this. Here 1, 2 is also large list with 2 elements. So therefore we should divide, right? 1, 1, 2, 2. Division point is 1, like this. Now time has come where I have to apply merge operation. This is my list with list L1 with only one element, list L2 with one element. So I need to merge these two to get the solution to this problem, right? So that is shown separately by means of a merge process. This is the combine process or the merge process or your conquer method, merge process. This will have 3 parameters, low, mid and high. अभी मैं बताऊंगा आपको procedure. low, mid and high. Why? I will tell you shortly. Just here you observe, initial my list was 110, right? Or I will write it here, 1 and 10. This we call it as low and this we call it as high. Please observe why there is a need to pass the middle element as the parameter. This is high. So mid value is 5. So my dear students, please observe, middle element 5 is acting as a boundary between the two subproblems. Middle element is always acting as a boundary between the two subproblems. So जब मैं indices initialize करूंगा I यहाँ पर, J यहाँ पर to compare, right? So this index I is set to, I mean the first list is exhausted if I crosses M and second list get exhausted if J crosses H. So that is the reason in merge process we have to pass the middle element, low, mid and high. Mid act as in boundary telling whether the first list is getting exhausted or second list. So जब मैं ये प्रॉब्लम को मर्ज कर रहा हूं, ये दोनों प्रॉब्लम्स को मर्ज कर रहा हूं, तो मेरा लो 1 है, हाई 2 है, मिड 1 है. So therefore the parameter that I pass are 1, 1, 2. That means I am merging these two elements 310 and 285. तो यहां पर 285 आ जाएगा और यहां पर 310 आ जाएगा. The list with two elements sorted. उसके बाद हम इसे पुश कर देंगे, अरे ए में बैक कॉपी कर देंगे, अरे ए में बैक कॉपी कर देंगे. तो क्या हो जाएगा, अरे ए आपका a of 1, a of 2, it become 285 and 310. This list is sorted. ठीक है, this list is sorted. Then you check simultaneously. When this problem is solved, I should work on this 3, 3, 3, 3. List with one element is already sorted. So we need to merge these two to get the solution to this problem. ये दोनों list को combine करना है to get the solution of problem having 3 elements. That is done by making a call to merge as 1, 2, 3. देखिए आप, low, mid and high. Low is 1, mid is 2, high is 3. So 1, 2, 3. So when you merge, let me rub off this. When you merge these two, 179, 285, 179 is small, then 285, then 310. This list is sorted. Update it back into array A at the same place. Update it back into array A at the same place. तो क्या हो जाएगा आपका, देखिए आप. So this will become 1, 2, 3, 179, 285 and 310. List is sorted. मैं सिर्फ एक ही साइड करूंगा, सेकंड साइड हम अज्यूम कर लेंगे ऑटोमेटिकली विदाउट वेस्टिंग टाइम. डोंट वरी. ठीक है. So this is temporary. देखिए आप how temporary array B is used in merging process. अगर आपके पास ये array ना हो, then you cannot achieve merging in the same array. You cannot do that. So that's why we require this. ठीक है. So I got the solution to this. Next I should work on for this 4, 5. It is large, list with 2 elements, so we should divide. Division point is 4 plus 5 by 2, 4. So therefore I will get list with 4, 4, 5, 5. These two are to be merged to get the solution to this. That is a new call to procedure merge as 4, 4, 5. 4, 4, 5. That means 652 and 351. तो पहले हम अरे बी में कॉपी कर लेंगे, यहाँ पर कॉपी कर लेंगे 351, 652. उसके बाद ए में रिफ्लेक्ट करेंगे 351 and 652. Right? 351 and 652. Very good. चलिए देखिए अब क्या होगा. Now I got the solution to this. Then I should merge these two now to get the solution of my first subproblem. मतलब this problem and this subproblem is to be merged by making a call of merge as 1, 3, 5. That means this is sorted list. This is also sorted list. We should merge these two. If you observe, they are already in order. देखिए 179, 285, 310, 350 and 652. Simply I will remove the boundary. Simply I will remove the boundary. I will remove the boundary. That's it. ठीक है. This 651. So my first list is totally sorted. Please observe that. My first list is totally sorted. I'm going to adopt the same procedure on the second. I'm going to adopt on the right hand side. So quickly I will complete the drawing of this so that you can have understanding. Division point of this is nothing but 8. So 6, 8, 9, 10. 6, 8 is again divided, right? 6, 7, 8, 8. Total tree I am completing. Please observe. 6, 6 and 7, 7. So these two are merged by making a call to procedure merge. यहाँ पर मैं कर रहा हूँ slightly up. First call to procedure merge on the right hand side 6, 6, 7. I get the solution to this. right? So this list is already sorted. So I need to merge these two to get this one. That is done by making a call to merge 678. 678. Once I get the solution to this, then I break up this into two parts. Division point is 9, 9, 9 and 10, 10. So these two are going to be merged by making a call to procedure merge here. 9, 9, 10. Okay? So I get the solution. Then I make a call to merge by combining these two to get the solution to this. That means this is to be merged. These two are to be merged by making a call as 6, 8, 10. 6, 8 and 10. That means this list is going to be sorted. यहाँ पर मैं sort कर लूँगा. So I will have 254, 423, 450, 520, 861. So that we need to update it back into array A. Update it back into array A. Please observe. So I'll get 254, 423, 450, 520, 861. These are array 8 indices. List is sorted. ठीक है? चलिए. Now we are coming to the last step. Combining these two subproblems to get the solution of this. That means merge this subproblem along with this. You get a call 1510. You make a call 1510. List is, again, that's a direct merging, is it not? 179 is compared with 254, so 179. Then 254, 285, 310, 351, 423, 450, 520, 651, 861. That's it. This list is sorted in array B, updated back into array A. Your A is sorted. That's it. This is merge sort. Very simple procedure. Okay. Based on these tree structures also there could be some potential simple questions that can be asked for 1 mark. Up next हम देखेंगे what is the performance of this. Come on, or maybe before performance, let us quickly glance through the code. Let us quickly glance through the code so that you can participate in the question answer session with regard to performance of this. Low and high are the indices of the array. Low and high are the indices of the array. Right? This may be 1, this may be 10. If low is less than high, matlab problem is large. When the problem is large, we should divide the problem into two subproblems about mid position. Solve the first left subproblem recursively. Solve the right subproblem recursively. जब दोनों के solution मिल जाएं, then you call merge. Low, mid and high, जैसा मैंने कहा. तो इसमें actual implementation जो आपको देखना है, वो है merge operation. Very interesting algorithm. चलिए, very quickly we'll have a glance through the merge operation. आपको एल्गोरिथम देखिए डियर स्टूडेंट्स, ये भी एक बात बताना चाह रहा हूं मैं. एग्जाम पर्सपेक्टिव में यू शुड आल्सो हैव द हैबिट, यू शुड आल्सो हैव द स्किल ऑफ रीडिंग द एल्गोरिथम एंड अंडरस्टैंडिंग इट. क्योंकि हमने पहले गेट क्वेश्चंस में देखे हैं कि दे गिव एल्गोरिथम विद सम ब्लैंक्स एंड देन दे विल आस्क यू टू फिल अप द ब्लैंक्स. तो अगर आप एल्गोरिथम को रीड प्रॉपर कर सकते हो तभी आप ब्लैंक्स फिल करेंगे. राइट? So this is the algorithm which I am trying to make you understand. We are initializing the index by name h pointing as low. I is initialized to low, j is initialized to mid plus 1. मतलब ये है कि जो first list है, list L1, the index pointing here is j, and for list L2, the index that is pointing here, sorry, this is h, not j, this is h, and this is j, right? This is low, and this is mid plus 1, and this high. ये है semantics. H is initialized to low, I is also initialized to low. Purpose of I will tell you. J is initialized to mid plus 1, check it, right? While H is less than or equal to mid means we have not exhausted the first list, and while J is less than or equal to high, means सेकेंड लिस्ट इज नॉट एग्जॉस्टेड. मतलब दोनों लिस्ट में अभी एलिमेंट्स है. अब हम क्या करेंगे, एलिमेंट कंपेयर करेंगे. इफ ए ऑफ एच इज लेस देन और इक्वल टू ए ऑफ जे, मतलब फर्स्ट लिस्ट का एलिमेंट स्मॉलर है. सो इन एरे टेम्पररी एरे बी ऑफ आई एम कॉपिंग ए ऑफ एच, इंक्रीमेंटिंग एच. अदरवाइज I will copy in B of I from the second list A of J and increment J, and further increment the value of I and go back. Repeat this until one of the list get exhausted. Repeat this until one of the list. तो आप बाहर लूप के बाहर आके आप चेक करेंगे कि कौन सी लिस्ट एग्जॉस्ट हुई. इफ H is greater than mid, look at that. If H is greater than mid, फर्स्ट लिस्ट इज एग्जॉस्टेड, मतलब आप सेकेंड लिस्ट से एलिमेंट्स कॉपी कर लेंगे, J to I यू कॉपी इन B of I, दैट्स इट, अदरवाइज यू कॉपी फ्रॉम द फर्स्ट लिस्ट। एंड फाइनली जब कॉपिंग हो जाएगी आपकी, फिर आप यू आर कॉपिंग बैक द अरे एलिमेंट फ्रॉम B to A। देखिए आप, so all the steps are very clearly described here. How to develop these habits is really hard. It's not really hard, Khadir. I mean, you read, as I have shown here, you read algorithms from textbooks, Corman की textbooks देखिए या साहनी की textbook देखिए, algorithm read कीजिए, or maybe even you can take some digital platforms and then there are some algorithms given, you read the algorithm from there, you develop a very natural skill of understanding the algorithm. देखिए हम कैसे understand किए, it's very simple, right? So based on this, let us now analyze the performance of this and answer the questions. Come on, answer the questions. So पहले हम analyze करेंगे performance analysis of merge sort. Performance analysis of merge sort working with n elements. सबसे पहले हम बात करेंगे time complexity. We want to find the time complexity. Let T of n represent the function, let T of n represent the time complexity of merge sort working on n inputs. So for all problems we have to express T of n in two cases. Come on, tell me what are the two cases. Two cases is when the problem is small and when the problem is large. हमने problem trace start करने से पहले ये understand किया था कि list having one element is small, right? So therefore if number of elements in the list is one element, मान लीजिए list has only one element, the list has only one element, it just take one comparison to determine that the problem is small. It requires only one comparison to determine that the problem is small and return, that's it. So therefore it take constant time. But invariably when n is greater than 1, can you write down the equation what will be T of n when the problem is large? Come on, tell me. That represent the time divide and conquer recurrence for merge sort. Come on, boys and girls, write down and tell me what will be T of n when the size of the problem n is greater than 1. What will it be? That will be interesting. What will be T of n? Yes, very good. Many people are writing directly. I hope you are not remembering and writing. Even if you remember and do it, very good. But अगर आप understanding से कर सकोगे ना तो बहुत अच्छी बात है वो. If you are remembering and telling, okay. लेकिन अगर आप understand करते हुए लिख रहे हो equation तो बहुत सीधी बात है. Will it be just n or will it be something more than n also? That's what I'm asking. Can you give me the exact equation? Can you give me the exact equation? Is it just n or n plus something else also? No, Bn is okay. In addition to that, do you require any other additional time? Okay, Bn is also right, no problem. चलिए लिखेंगे हम, देखिए ऐसा सॉल्व करेंगे हम. This is my problem of input size n. I am saying time for solving it is T of n. T of n. ठीक है. When the problem is large, what are we doing? We are dividing this into two sub-problems, each having roughly n by 2 elements. So therefore, listen, this is like my list L1 and this is like list L2. Please follow me. Please follow me carefully. Interpretation is important. So to sort this list L1 having n by 2 elements, the time needed will be recursively Tn by 2. And to solve this problem, to sort this list L2 having n by 2 elements, the time needed will be T of n by 2 recursively. ये तो समझ में ही डायरेक्ट बात है. Yeah, Mahek, very good evening. So T of n by 2, please T of n by 2. So my dear boys and girls, list L1 को सॉर्ट करने के लिए हमें टाइम लगेगा Tn by 2 रिकर्सिवली. लिस्ट L2 को सॉर्ट करने के लिए हमें टाइम लगेगा T of n by 2. उसके बाद हमें क्या चाहिए? हमें मर्ज करना चाहिए. हमने जो आज सेशन में स्टार्ट किया था, देखिए आप, लिस्ट L1 having n1 element, n by 2 elements, list L2 having n by 2 elements. So therefore, to merge these two, what is the time needed? Come on, boys and girls, ये बताइए मुझे. What is the time needed? Exact time बताइए मुझे. मर्जिंग के लिए कितना टाइम लगेगा? मर्जिंग के लिए कितना टाइम लगेगा? हमने ऑलरेडी देखा पहले जब मैंने स्टार्ट किया था सेशन. जब आप बोलेंगे सर टाइम, आप पूछ सकते हो मुझसे सर मिनिमम टाइम या मैक्सिमम टाइम, बेस्ट केस पूछ रहे हो या वर्स्ट केस पूछ रहे हो, मिनिमम या मैक्सिमम, दोनों बताइए। यही बेसिस पर तो मर्ज सॉर्ट की कॉम्प्लेक्सिटी की हम यूनिफॉर्मिटी की बात करते हैं। कम ऑन, अगर आप मिनिमम पूछेंगे तो कितना होगा टाइम, बोलिए मिनिमम टाइम कितना होगा। नंबर ऑफ कंपैरिजंस की अगर बात करेंगे, नंबर ऑफ कंपैरिजंस मिनिमम फॉर मर्जिंग दीज टू लिस्ट, for merging these two list L1 having n by 2 elements, list L2 having n by 2 elements, minimum number of comparisons is n by 2, is it not? And maximum number of comparisons is n by 2 plus n by 2 minus 1, that is n minus 1. Please observe, ये बात आप शायद गौर ना की होगी। मिनिमम इज n by 2, नॉट n1 and n1 n2 है नहीं यहां पर। अजान अमीन, देयर इज नो n1 and n2, दिस n by 2, दिस n by 2, दोनों सेम है। तो मिनिमम नंबर ऑफ कंपैरिजंस इज n by 2, मैक्सिमम नंबर ऑफ कंपैरिजंस इज n by 2 प्लस n by 2 minus 1, n1 प्लस n2 minus 1, समझ रहे हो बात? सो मैक्सिमम टाइम इज n minus 1, मिनिमम टाइम इज n by 2, राइट? अगर आप इसको ऑर्डर ले लेंगे तो दिस इज ऑर्डर ऑफ n and this is also order of n. So that is why we write the time for merging, whether it is minimum or maximum, both is order of n, both is order of n, both is order of n, both is order of n. वो कैसे order of n आया? इस तरीके से आया। अगर मिनिमम वुड नॉट, अगर मिनिमम अगर n ना होता तो हमारी टाइम कॉम्प्लेक्सिटी बेस्ट केस की अलग हो जाती और वर्स्ट केस की अलग हो जाती। ये बात आप हमेशा याद रखिए, ये बहुत इंपॉर्टेंट बात है। अगर मिनिमम n ना होता, n by 2 अगर ना होता, ऑर्डर ऑफ n ना होता, तो हम टाइम कॉम्प्लेक्सिटी इन मिनिमम ऑफ वर्ड सॉर्ट वुड हैव बीन डिफरेंट एंड वर्स्ट केस वुड हैव बीन डिफरेंट। बेस्ट केस और वर्स्ट केस सेम इसीलिए आ रहे हैं कि बोथ केसेस आर ऑर्डर ऑफ n, बोथ केसेस आर ऑर्डर ऑफ n। ये बात आई होप यू गॉट माई पॉइंट व्हाट आई एम ट्राइंग टू से। बोथ आर ऑर्डर ऑफ n, दैट इज व्हाई वी आर सेइंग इट इज ऑर्डर ऑफ n। तो चलिए रिकरेंस क्या हो जाएगा प्लीज? रिकरेंस बन जाएगा आपका 2t of n by 2 plus you can add some constant for checking that the problem is large and problem for dividing, right? You can add the constants and then add it to the function. So function plus constant is always order of n. So nothing wrong, I can write this as for example order of n. Actually if you want me to write, it can be something like a constant a for checking that the problem is large, a constant b for checking that the problem is small, plus order of n. So again, if I take the order of this function, this will again be order of n. So that is why I write it like 2t n by 2 plus some order of n, right? Some whole order of n. So if you don't want to write in terms of order of n, maybe you can write it like some bn, where b is a constant, b is greater than 1. So this become my recurrence for merge sort, representing the time complexity. Representing the time complexity. Okay? These are recurrence. You have to remember the recurrence now. You can solve this recurrence using back substitution method, right? Or you can solve it using, there are three approaches you can use to solve this recurrence. Either you can use back substitution, or you can use master method, or even you can solve it using recursion tree method. Either of these approaches, right? Back substitution, अगर आपको cases याद हो मास्टर मेथड के, तो आप डायरेक्टली केस अप्लाई करके कह सकते हो आंसर केस 2 अप्लाई होता है, राइट? केस 2a, केस 2 में भी केसेस है 2a, 2b, 2c like that, right? Case 1, case 2, case 3. There are 3 cases in master method. I'm not going to cover up, but I'm presuming that you know it, because that is not in my agenda of crash course. ठीक है? तो मास्टर मेथड करते हैं। अगर मास्टर मेथड में आपको किसी भी तरह का कंफ्यूजन हो रहा हो तो आप सीधा बैक सब्स्टिट्यूशन लीजिए। बैक सब्स्टिट्यूशन में किसी किस्म का आपको कोई कंफ्यूजन ना होगा, राइट? I would say in as much as almost the same time you can get the solution to the problem using back substitution also. So chaliye, when you solve this, what will you get t of n as? Order of, come on, order of what? This gets simplified to what? When you simplify this and get a function, you will get a function something like this. I will directly, using back substitution, you will get a function something like this: cn log n plus bn, something like this, cn log n plus bn, something like this. After back substitution, you will get it some equation like c is a constant, b is a constant. So cn log n plus bn. So if you take the order of that, if you take the order of it, then order is order of n log n. And then if you take omega of it, then omega is also omega of n log n. Therefore, based on this, I say that the time complexity of merge sort is order and omega are same. So I write theta of n log n. Theta of n log n का मतलब ये है कि यूनिफॉर्म टाइम यूनिफॉर्म का मतलब नॉट कांस्टेंट, यूनिफॉर्म का मतलब whether elements are in increasing order, decreasing order or any order, the merge sort will not have any turbulent behavior. Turbulent का मतलब मेरी अपनी टर्मिनोलॉजी है. Turbulent का मतलब ऐसा है कि sometime for some case of input ज़्यादा time ले रहा है, for other case of input it is taking less time, and other case of input it is taking more time. No, non-turbulent behavior, uniform behavior. Elements are in increasing order, decreasing order, random order, partial increasing, partial decreasing, or any total random. Time complexity will be unwavering n log n. That's it. Best and worst are same n log n. ठीक है, ये तो हो गया. अब मुझे नेक्स्ट पेज पे बताइए, और मे बी प्रीवियस पेज में बताइए, यहां पर बेस्ड ऑन दिस स्लाइड, व्हाट इज द स्पेस रिक्वायरमेंट ऑफ मर्ज सॉर्ट. कम ऑन, स्पेस कॉम्प्लेक्सिटी इक्वेशन लिख दीजिए पहले, फिर उसके बाद आप असिम्प्टोटिक ऑर्डर अप्लाई कीजिए. व्हाट इज द स्पेस कॉम्प्लेक्सिटी ऑफ मर्ज सॉर्ट. कम ऑन बॉयज एंड गर्ल्स, what is the space complexity of merge sort? Nobody knows? Order of n. पहले इक्वेशन लिखिए क्या होगा. या एस वाई यू आर राइट, इट इज n, लेकिन इक्वेशन लिखिए क्या है. या वेरी करेक्ट. सम कांस्टेंट स्पेस फॉर सम वेरिएबल्स प्लस आई ऑल्सो नीड स्पेस फॉर दिस अरे b n, plus I need recursion stack. So the depth of this stack, as you see, is log n, as we have been seeing for the last few lectures. So c plus n plus log n is the exact component of space. So if you take the order of this, is order of n, omega of n, theta of n. So it always is order of n. So in this regard, we say that merge sort has the limitation or the drawback that it requires an additional space or space complexity order of n, which is more than order of 1. And such sorting techniques, let me ask this question, such sorting techniques that take more additional space, more than constant or more than log n for stack, more than log n, are generally termed as dash sorting techniques. What do you call this sorting technique whose space complexity is more than a constant or more than a log n complexity? What do you call such sorting techniques in the literature of outplace? Yeah. Outplace, or better term you can say not in place. Merge sort is not in place sorting. Outplace or not in place? Yes, not in place. A sorting method is said to be in place if its space complexity is either order of 1 or at most order of log n. That's it, and that too log n is basically for recursion stack. So therefore merge sort का एक drawback है कि this is not in place because it requires an additional array of size n, which is equal to the input array size. Yes, very good. So this is all about merge sort. अब इसके और कुछ variations हैं, मैं आपको बताना चाह रहा हूँ. I mean I cannot cover up here, right? Just a second. There are two versions of merge sort. I want you to get yourself familiarized. अगर आपने ना पढ़ा हो तो please पढ़ लीजिए later. You can get that information, or you can get that in several textbooks of algorithms. Variations of merge sort which I want you to work out. Variations of merge sort. सबसे पहले है implementation of merge sort with links. With links. मतलब हम यहां पर क्या कर रहे हो, एलिमेंट को एज इट इज टोटल एलिमेंट को स्वैप कर रहे हो, उसके लिए शायद टाइम ज्यादा लगेगा. उसके बजाय अगर हम एलिमेंट अगर बड़े नंबर्स हो, राइट, लार्ज नंबर्स हो, उसको कॉपी करने के लिए टाइम कंज्यूमिंग ऑपरेशन होगा. उसके बजाय अगर हम पॉइंटर्स रखेंगे, लिंक्स रखेंगे पॉइंटिंग टू एलिमेंट्स, और पॉइंटर्स की साइजेस अगर छोटी हो, राइट, इंडिसेस के साइज छोटे हो, then moving the indices will take less time. So that is one way of optimizing time. So that this is one variation of merge sort you can study from the textbook. And second, there is another variation of merge sort. Do you know? There was a gate question on that. What is the second variation of merge sort popularly known as? Come on, write it in the chat box. Let me see. whether you are knowledgeable or not. What is the second variation of merge sort? Which is in principle based on divide and conquer only, but a slight variation than in comparison to this traditional merge sort. What is that second version? What is it known as? जिसके basis पर gate question भी आया था. What is that? Do you know it? Very good, very good, very good. People are knowledgeable. So that is called two-way merge sort. Two-way merge sort. It is also called bottom-up merge sort. Bottom-up merge sort. इसमें हम divide process नहीं use करेंगे, only combine. Divide is not used, only combine. In two-way merge sort or bottom-up merge sort, we only use divide. So my advice is to complete this process of merge sort comprehensively. You cover up this topic also. That should be more than sufficient enough. Okay. Some very simple and interesting questions were asked in earlier papers on merge sort. एक क्वेश्चन है, हम वो भी डिस्कस करेंगे लेटर, लेकिन उससे पहले मैं चाहूँगा एक प्रॉब्लम हम डिस्कस करें, और एक जिसका टॉपिक आज जो टॉपिक में लिखा गया था वो है मैट्रिक्स मल्टीप्लिकेशन. दिस इज अ वेरी सिंपल प्रॉब्लम, लेट अस कवर इट. उसके बाद हम दूसरे प्रॉब्लम्स को जनरल डिस्कस करेंगे. वी कैन नॉट गो इनटू डिटेल्स, बट वी विल हैव ए जनरल डिस्कशन. मैट्रिक्स मल्टीप्लिकेशन. Yeah, first implementation from Corman, I don't think Khadir you can get. First implementation using links you can see from the textbook of Sahani. Sahani textbook may merge sort with links. Okay, two merge sort you can find in Corman also. Fine. Matrix multiplication. So what is the problem definition? Given three matrices A, B, C of order n cross n. That means square matrices. Number of rows equal to number of columns. Such matrices are called square matrices. So we are given three matrices A, B, C. Of course given A, B and we have to find C. लेकिन हम dimensions में बता रहे हैं यहाँ पर. My first question to you. What is the time complexity to add or subtract the two matrices A and B to get the resultant matrix C? Time complexity. Come on. Using your school method, using your general method which you studied at your school or first level course of programming, जब आप कर रहे हो तो first level course of programming, what is the time complexity to add or subtract two matrices of order n cross n? Add or subtract. कितना time लगेगा? What is the time complexity? Come on. Order of n square. Very correct. So this will be order of n square. क्यों? You have to write two loops. For I is equal to 1 to n, for j is equal to 1 to n, you will have to say that C of ij is equal to A of ij plus or minus whatever B of ij. That's it. So this will give you straight away the sum or difference matrix. Like that, using the traditional school method to get the product matrix. This is school method I am saying. School method का मतलब non divide and conquer. School method non divide and conquer. What is the time complexity? To multiply two square matrices of order n cross n. To multiply. Multiply करने के लिए क्या time complexity लगेगी? To multiply two square matrices using non divide and conquer method. That is order of n cube. वो भी बहुत simple process है. Right, you will have to write like for I is equal to 1 to n, for k is equal to 1 to n. You will have to initialize element Cik is equal to 0. Then you will have to write the third loop for j is equal to 1 to n. For j is equal to 1 to n. You will have to write like Cik is equal to Cik plus, so therefore plus equal to Aij into Bjk. Row multiplied by column, something like this. So therefore straight away I have three nested loops in going in depth. So time complexity of this will be order or theta of n cube. School method, non-divide and conquer method. Now we will have to explore and find out, is it possible to multiply the two square matrices of order n cross n using the principle of divide and conquer? If so, how and at what cost? What cost का मतलब what will be the time complexity? That we will have to see. So here we are exploring, is it possible to have a divide and conquer approach for multiplying the two square matrices of order n cross n. तो हम एक रियलिस्टिक एग्जांपल ले लेंगे, मैट्रिक्स ए मैट्रिक्स बी, राइट, और मे बी आई विल स्लाइटली स्क्वीज इट. Matrix A and matrix B here, right? I want to multiply them, and here is my matrix C. Let us say these 4 by 4 matrix, these 4 by 4 matrix, these 4 by 4 matrix, right? You can take elements like 1, 2, 3, 4, some elements 5, 6, 7, 8, 9, 1, 2, 5, 5, 6, 1, 2, and here you can take like A, B, C, D, K, L, M, N, P, Q, R, S, T, something like this, right? So when I'm working the problem based on divide and conquer, we should divide the problem into sub-problems until it becomes small. So following the previous paradigms, if I follow division like 4 by 4 getting divided into matrices of order 2 by 2, 4 by 4 divided by 2 by 2, or dividing into equal halves. So therefore I can view the matrices like this. 4 2 by 2 matrices like this. That means problem is divided into half size. Matrix A divided, which is of size 4 by 4, got divided into 4 2 by 2 matrix. 4 2 by 2 matrix. Same way you can visualize matrix C also of 4 2 by 2 matrices. You call this as C11, C12, C21, C22. This matrix, the first submatrix, you call it as A11, this as A12, this as A21, this as A22. Similarly, this will be B11, B12, B21, P22. So for your convenience I am writing Aij, Bij, Cij are matrices of order n by 2 by n by 2 at the first level of recursion. 2 by 2 at the first level of recursion. ठीक है. So as per equation, you know the procedure, right? You know the procedure. Based on the procedure, the equation C11 is nothing but row of A multiplied by column of B, that is A11 into B11 plus A12 into B21, equation 1. My dear students, kindly observe here, A11 and B11 are not element multiplication, they are submatrix multiplication of order n by 2 by n by 2. One submatrix multiplication, another submatrix multiplication in equation 1. After that, the merge operation is like, conquer operation is like addition. Solving the subproblem, then adding them. So this is my conquer. Similarly, next element C12, row multiplied by second column. So ये बन जाएगी आपकी matrix A11 into B12 plus A12 into B22, equation 2. यहाँ पर भी दो multiplications, एक addition. C21 क्या हो जाएगी आपकी? Second row multiplied by first column. तो A21 into B11 plus A22 into B21, equation 3. फिर लास्ट इक्वेशन आपकी हो जाएगी C22 as A21 into B12 plus A22 into B22, equation 4. ये 4 इक्वेशन से आपको टोटल मैट्रिक्स C मिल जाएगी. मतलब अब नाउ व्हेन शैल वी कंसीडर द प्रॉब्लम टू बी स्मॉल. अगर मान लीजिए द वैल्यू ऑफ n वुड हैव बीन 16 by 16, फर्स्ट लेवल ऑफ रिकर्शन आप 8 by 8 में डिवाइड करोगे, सेकंड लेवल पे 4 by 4 पे डिवाइड करोगे, नेक्स्ट लेवल पे 2 by 2 पे करोगे, लास्ट लेवल यू कैन से 1 by 1. 1 by 1 मैट्रिक्स मीन सिंगल एलिमेंट. सिंगल टाइम टू मल्टीप्लाई टू सिंगल एलिमेंट, टू स्केलर एलिमेंट्स इज कांस्टेंट. मतलब ये है कि यू आर कंटिन्यूइंग टू डिवाइड द प्रॉब्लम इनटू सब प्रॉब्लम अंटिल इट रिड्यूसेस डाउन टू ए स्केलर एलिमेंट. ठीक है, वेर इन these two become two scalar, 1 by 1 matrix you are multiplying and then adding, so time become constant. Till that time you have to basically continue to divide. So based on this you can see what will be the equation for solving this problem. Based on this, what will be the equation for solving this time complexity equation, recurrence. यहाँ पे मैं थोड़ा squeeze कर दूं, यहीं पे करेंगे और next page पे करेंगे. Okay, we'll do it here. We'll do it here. ठीक है, तो यहाँ पे लिख दूं मैं 16 by 16, for example, as a case is getting divided as 8 by 8, then 4 by 4, then 2 by 2, then 1 by 1, something like this. So if I assume time complexity is given by for a function, for example, let T of n represent time complexity of divide and conquer matrix multiplication of order n cross n matrix, then how will you draft the equation T of n? Come on. When the value of n is 1 by 1 matrix, time taken for multiplication is constant. When n is greater than 1, for example, then what will be the time complexity? Problem is large and problem is small. How will I write the equation? Come on, how will I write the equation when the problem is large? अगर यहाँ आप strictly speaking n less than or equal to 2, अगर आप 2 by 2 matrix लेंगे, then also this will become constant. So even if you write n is less than or equal to 2 constant, n greater than 2, you can say problem is large, there is no problem. That means what I am saying, you can even write n less than or equal to 2, or here instead of saying greater than 1, you can say n greater than 2. What will be the equation on the right hand side? Come on. How many is, look at this. In this equation, 4 equations, 1, 2, 3, 4 equations, how many multiplications, sub-matrix multiplications are taking place? 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8, each of size n by 2 by n by 2. So time for multiplying 2 square matrices is T of n. n by n के लिए T of n है. n by 2 by n by 2 n के लिए टाइम कितना होगा? Tn by 2. तो मतलब एक मैट्रिक्स मल्टीप्लिकेशन के लिए टाइम Tn by 2 प्लस अनदर Tn by 2, अनदर Tn by 2, अनदर Tn by 2. इस तरीके से यू रिक्वायर 8 मल्टीप्लिकेशंस ऑफ साइज Tn by 2. So Tn by 8, Tn by 2 plus I need some additions also. I need some additions. 4 additions are needed. Time to add 2 matrices of order n cross n is order of n square. उसी तरह time to add 2 matrices, square matrices of order n by 2 by n by 2 will also be order of n square. क्यों? क्योंकि आप लिखेंगे for I is equal to 1 to n by 2, for j is equal to 1 to n by 2, you will write it like a of ij is equal to c of ij is equal to a of ij plus b of ij. That is order of n square by 4. Order of n square by 4 is order of n square. So this is some constant bn square. B is a constant. So this become my equation. So you have to remember this equation T of n representing the time complexity value for divide and conquer method. आप चाहे तो बेस्ट बैक सब्स्टिट्यूशन से सॉल्व कर सकते हो जैसा मैंने पहले कहा, या इफ नॉट बैक सब्स्टिट्यूशन मास्टर मेथड में दिस केस डायरेक्टली अप्लाई, राइट? So the function f of n is n square, f of n square, right? We can say like that. The function f of n is my function f of n. Is it order of n power log a to base b, log 8 to base 3, sorry base 2, log a to base b, minus epsilon. Case 1 में minus epsilon है, log 8 to base 2 minus epsilon. F of n is n square. Can I say n square is it order of n power log 8 to base p 3 minus epsilon? Yes. Particularly if you take epsilon equal to 1, basically it satisfies. Therefore we conclude that T of n is theta of n power log 8 to base b, case 1 of master method, order of n cube. The time complexity of this is order of n cube. लेकिन क्या मुझे कोई बताएगा what is the drawback? So हम क्या कर रहे हो? Using school method also is order of n cube, using divide and conquer also it is order of n cube. So there is no relaxation, there is no respite. Respite मतलब कोई relief नहीं है आपको, time complexity में कोई relief नहीं है. लेकिन स्ट्रेट फॉरवर्ड इंप्लीमेंटेशन जो यहां पर हमने दिखाया था, द स्पेस कॉम्प्लेक्सिटी ऑफ दिस इज नथिंग बट ऑर्डर ऑफ एन. लेकिन इसकी स्पेस कॉम्प्लेक्सिटी क्या होगी? डिवाइड एंड कॉन्कर की स्पेस कॉम्प्लेक्सिटी क्या होगी? कम ऑन समबडी, व्हाट विल बी द स्पेस कॉम्प्लेक्सिटी ऑफ डिवाइड एंड कॉन्कर मेथड ऑफ मैट्रिक्स मल्टीप्लिकेशन? व्हाट विल बी द स्पेस कॉम्प्लेक्सिटी ऑफ डिवाइड एंड कॉन्कर मेथड ऑफ मैट्रिक्स मल्टीप्लिकेशन? कम ऑन बॉयज एंड गर्ल्स. log n. क्यों? क्योंकि we require recursion depth just like recursive call जो हो रहा है n by n है, n by 2, n by 4, n by 8, just like merge sort और binary search. So therefore this is order of log n. तो हम ये कह रहे हैं कि space wise this is not better. Divide and conquer method is not better space wise. Space wise non divide and conquer method is better. So how the question is ultimately how to reduce the time complexity. How to reduce the time complexity. reduce time complexity. So for this, a famous mathematician by name Strassen carried out a simple research with an intention to reduce the complexity from order of n cube to a lesser value. With a simple observation. Observation क्या था? Observation of Strassen was that multiplication can be done by repeated addition. A into b is nothing but a multiplied by b is nothing but adding a b times. So with that observation, what he did was he carried out a research with an intention to reduce the number of, अब देखिए आप divide and conquer में जो number of multiplication सब matrix multiplication जो लग रहे हैं 8 है, 8 1 2 3 4 5 6 7 8. अगर हम मान लीजिए 8 से कुछ less number of multiplications कर लेंगे, 8 से अगर less करेंगे, then our complexity will come down. So that was with that intention of reducing the number of multiplication. This is the research of Strassen's approach, which is essentially again based on divide and conquer. Inherently divide and conquer ही है. But he has given new equations. Look at this. He has given new equations for C11, C12, C21, C22. So for that, what he has done, he has introduced some 7 additional matrices by name P, Q, R, S, T, U, V. These are also initially of order n by 2 by n by 2 matrices, like our original matrices Aij, Bij. So in addition to Aij, Bij, which are also of n by 2 by n by 2 matrices, we are using this additional matrices also. Okay? To basically perform the manipulation. So what Strassen has done, he has given new equations for matrices P, Q, R, S, T, U, V as follows. He said that P should be like A11 plus A22 multiplied by B11 plus B22. This is multiplied by. So if you look at all these 7 equations, how many multiplications are taking place in this? How many multiplications? 7. 1, 2, 3, 4, 5, 6, 7. 7 multiplications. Okay? So as such, in these equations, we are requiring 7 multiplications. Each of what order? N by 2 by n by 2 at the first level of recursion. Here, in addition to that, we need some additions and subtractions. If you look at that, additions and subtractions. How many additions and subtractions totally will count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't forget this: 11, 12, 13, 14, 15, 16, 17, 18. A total of 18 additions and subtractions. Both milake, dono milake, additions and subtractions, we have 18. And these matrices are also of order n by 2 by n by 2. तो अगर आप इक्वेशन ड्राफ्ट करोगे स्ट्रासन का टाइम कॉम्प्लेक्सिटी इक्वेशन, तो क्या बन जाएगा? इज इक्वल टू सम कांस्टेंट फॉर n लेस देन और इक्वल टू 2 and will become 70n by 2. देखिए, अगर आपके पास 18 additions हो या 4 additions हो, time complexity for addition will always be order of n square. So therefore this will be again b of n square for n greater than 2. So this become my time complexity recurrence for Strassen's approach. और अगर आप ये सिर्फ बैक सब्स्टिट्यूशन से सॉल्व करोगे या फिर मास्टर मेथड अप्लाई करोगे, केस वन अप्लाई करेगा, केस वन अप्लाई होगा मास्टर मेथड का, बिकॉज वी विल से दैट एफ ऑफ एन इज ऑर्डर ऑफ n पावर log 7 to base 2 माइनस एप्सिलॉन. केस वन ऑफ मास्टर मेथड ये अप्लाई होगा बिकॉज log 7 to base 2 की वैल्यू क्या है? log 7 to base 2 की वैल्यू है 2.81, बिकॉज log 3 to base 2 इज 3, तो लेस देन 3 होगी वो, 2.81 है, यू कैन चेक इट. So therefore case 1 apply, and by case 1 we say that this is n power 2.81. This is the time complexity of Strassen method. So Strassen was able to reduce the time complexity from basically order of n cube to a lesser value, order of n power 2.81. ये है approach of Strassen's method. ठीक है? So this was my intention basically to discuss with regard to the problems of divide and conquer. अब बाकी के जो problems है हम एक sort of revision के type में करेंगे. Just have a look at it. Like I just ask the questions, you try to respond to them. Like the another problem that we generally discuss is binary search. You all know binary search, I don't have to tell you, and neither I am going to describe how it actually works. Do you agree that binary search is also based on divide and conquer methodology? Say yes or no. Do you agree with me that binary search is also based on divide and conquer methodology? Binary search. Is it also based on divide and conquer methodology? Come on, boys and girls. Is it also based on divide? Yes, it is based. Second question. Does binary search uses both divide and combine? I'm putting the question here. Does binary search uses both divide and conquer, both of them, or just use the principle of divide? Only divide. Correct. Only divide. It does not use the concept of conquer. Okay. Next question. My question answer based way. I'm solving this problem interactively. Come on, answer me. Suppose for example my problem instance is I. आपको binary search पता है. We are having n elements. Those elements are a1 to an, and I want to locate for x. I want to search for x. If I represent my problem like this, n is the number of elements, a1 to an. X is the element that I am searching for. List is already sorted. चलिए, when shall I consider this problem to be small? List having how many elements? List having how many elements shall we consider this problem to be small? List having how many elements should we consider this problem to be small? List having, come on, list L or instance I having how many elements shall we consider the problem to be small? Only one element A. Is it not? Only one element. अगर element if it is more than one, then the problem is large. हाँ चलिए, problem अगर large हो, assume that n is greater than 1 here. When the problem is large, this is my interesting question. Generally जब मैं students को पूछता हूँ तो very few could answer correctly. Let me see your batch. When the problem is large in binary search, when the problem is large, बोलिए, when the problem is large, into how many sub problems? The original problem having n elements get divided into. Boys and girls, एक बार फिर से सुन लीजिए. When the problem is large, then the larger problem initially in the first step get divided into how many sub problems? Think carefully and tell. जैसा हमने मर्ज सॉर्ट में देखा 2 सब प्रॉब्लम में डिवाइड होगा, मैक्समिन में देखा 2 सब प्रॉब्लम में डिवाइड होगा, उसी तरह यहां पर बताइए. आपने बाइनरी सर्च पढ़ा है, आपको पता है. So in binary search, into how many sub problems will the original problem get divided into? Very good. Preetham Swain, you are saying 3. What about others? Rakesh Gupta, Rahatullah, Vandana, Kadir, Prashant. How many sub problems? 3 sub problems. Very good. Do everybody say 3? हर कोई 3 बोलेगा? क्या हर कोई 3 कंसिडर करेंगे? लेफ्ट और राइट, देन प्रॉब्लम इज बिग. ओके, नॉट श्योर. ओके, नो प्रॉब्लम. चलिए देखिए, आप बाइनरी सर्च में क्या होगा. अगर मान लीजिए आपके पास 7 एलिमेंट्स होंगे तो क्या करेंगे आप? पहले मिडिल एलिमेंट फाइंड करेंगे ना. मिडिल एलिमेंट होगा 4. फिर उसके बाद अगर x की कंपेयर करेंगे 4 से, अगर 4 के अगर मैच नहीं हुआ, देन यू विल सर्च इन द लेफ्ट सब प्रॉब्लम. ठीक है. और इफ इट इज x इज लेस देन a of 4, if x is less than a of 4, then you search in the left. If x is greater than a of 4, then you search in the right. राइट में आप होगा 5 to 7. तो देखिए आप 3 सब प्रॉब्लम्स हो गए. ये मिडिल का भी एक सब प्रॉब्लम है, लेफ्ट का एक सब प्रॉब्लम है, राइट का सब प्रॉब्लम. तो ये 3 सब प्रॉब्लम्स होंगे. 3 मिडिल एलिमेंट से मिड, राइट. m is nothing but 1 plus n by 2 m. तो इंस्टेंस I2 बोलेंगे हम, ये इंस्टेंस I1 बोलेंगे, और लास्ट इधर बोलेंगे इंस्टेंस I3. इंस्टेंस I2 में सिर्फ एक ही एलिमेंट रहेगा, a of m एंड x. लेफ्ट सब प्रॉब्लम में m-1 एलिमेंट्स होंगे. व्हाट आर दोज एलिमेंट्स? a1 to am-1, और आप सर्च करोगे x को. I3 में क्या? इतने रिमेनिंग n-m एलिमेंट्स होंगे, स्टार्टिंग फ्रॉम m+1 to n, एंड यू आर सर्चिंग फॉर x. Right, 3 sub problems. 1, 2, 3. This is my left about mid, and this is the right about mid. I will solve this sub problem if x is less than a mid. I will solve this sub problem if x is greater than a mid. Right? So इस basis पर सेकेंड इंपॉर्टेंट कैरेक्टरिस्टिक जो है बाइनरी सर्च की वो ये है, जनरली हम डिवाइड एंड कॉन्कर में देखते हैं व्हेन वी डिवाइड द प्रॉब्लम इनटू सब प्रॉब्लम्स, हम पूरे सब प्रॉब्लम सॉल्व करते हैं। लेकिन बाइनरी सर्च में आप देखिए, वी आर नॉट सॉल्विंग ऑल द थ्री, वी आर नॉट सॉल्विंग ऑल द थ्री। हाउ मेनी वी आर सॉल्विंग? बताइए, इन द फर्स्ट लेवल हाउ मेनी सब प्रॉब्लम्स आर वी सॉल्विंग? कम ऑन, हाउ मेनी सब प्रॉब्लम्स आर वी सॉल्विंग? आर वी सॉल्विंग ऑल द थ्री? नो, वी आर नॉट सॉल्विंग ऑल द थ्री। तो कितने सब प्रॉब्लम सॉल्व कर रहे हैं? वी आर सॉल्विंग टू आउट ऑफ थ्री। वी विल फर्स्ट सॉल्व I2 कंपल्सरी। I2 सॉल्व करने के बाद इफ आई डोंट गेट द रिजल्ट, आइदर आई सॉल्व L और आई सॉल्व R, आई विल नॉट सॉल्व बोथ। तो ये बेसिस पर हम टाइम कॉम्प्लेक्सिटी रिकरेंस बनाते हैं बाइनरी सर्च का, T of n। दिस वाज आस्क्ड, आई रिमेंबर, गेट 1 mark क्वेश्चन। The question asked was, if T of n represent the time complexity for binary search with n elements, boys and girls, pay attention. If T of n represent the time complexity of binary search, right, with n elements, then what is the recurrence that arises for divide and conquer binary search? Come on. What is the recurrence? Recurrence क्या होगी? What is the recurrence for binary search? What is the recurrence for binary search? T of n will be what? Constant boundary condition तो हम लिख देंगे some constant c when n is equal to 1। अगर मान लीजिए आपके लिस्ट में एक ही एलिमेंट हो तो T of n is equal to 1। अगर ना हो, एक एलिमेंट से बढ़ के एलिमेंट्स हो अरे में, n greater than 1, problem is large, तो what will be T of n? What will be T of n? Very good, very good, very good. T of n will be time for solving A2, which is a constant time A, time for divide constant, time for checking that the problem is large constant, constant plus constant plus constant is a constant A, plus then I solve either L or R. So this list has n elements. Roughly for large values of n, this list will have n by 2 elements. This list roughly will have n by 2 elements. So time for solving list with n by 2 elements will be Tn by 2. So recurrence that arises for binary search will be T of n is equal to T of n by 2 plus constant. If you solve this is order of log n, and that is the worst case complexity of binary search. Okay, assuming a symmetric division, not like a skewed tree, symmetric division. This is binary search, right? So like that you can study other problems also, like one of the prominent problems, जो मैं खाली यहाँ पे list करके आपको बता दूंगा, you can study other problems of divide and conquer, right, from the perspective of gate. One of the prominent problem which you have to make a study, based on which there were many questions asked in earlier papers, quick sort, also called partition exchange sort. It is based on pivoting process or partitioning process. Pivoting or partitioning process. Okay? Then other than that, there are other problems, like for example, one more problem is there called long integer multiplication. This is also a star problem. You can expect some questions on this. Long integer multiplication. This is somewhat similar to matrix multiplication, but slight difference. Long integer multiplication. Generally we write in short LIM. In the exercise of Corman textbook, you can find the description of LIM, or on internet also you can get it. Yes, more than 2 sub problems. I1, I2, I3. Khadir, check the previous slide. We are dividing the problem into 3 sub problems, more than 2. I1, I2, I3, but we are not solving all the 3. We are solving only 2 out of 3. Okay? Okay. Long integer multiplication. I will just quickly tell you what is the background behind LIM, long integer multiplication. Please see on board. Suppose if I give you 2 integers A and B, right? Point number 1, if you want to add or subtract them to get a resultant C, the time complexity will be order of 1. If you want to multiply them together to get the product C, time complexity will be order of 1. लेकिन आपने पढ़ा होगा प्रोग्रामिंग में, प्रोग्रामिंग इन सी और भी कोई प्रोग्रामिंग कोर्स में, जब हम इंटीजर की बात करते हैं, जनरली इंटीजर इज इन नॉर्मल इंटीजर्स में टेक 4 bytes, and with 4 bytes of data you will have a finite number, maximum number that you can represent. You cannot represent, maybe I can say that you can represent, let us say, some 6-digit number maximum with 4 bytes of data, 6 डिजिट नंबर। लेकिन मान लीजिए कई ऐसे साइंटिफिक एप्लीकेशंस है, कई ऐसे मैथमेटिकल एप्लीकेशंस है जहां पर आपके पास काफी बड़े बड़े इंटीजर्स होंगे, लॉन्ग इंटीजर्स होंगे। मे बी यू कैन हैव इंटीजर्स ऑफ 100 डिजिट्स, मे बी यू कैन हैव इंटीजर्स ऑफ 1000 डिजिट्स। तो आप जब इंटीजर रहेंगे 1000 डिजिट्स के, या इन जनरल अगर हम बात कर लेंगे, टू लॉन्ग इंटीजर्स, टू लॉन्ग इंटीजर्स ऑफ n digits each, n digits बोलिए या n bits बोलिए, digits each, then question is how do you represent them? सबसे पहला आपका क्वेश्चन आएगा, आप उसे कैसे रिप्रेजेंट करेंगे। आपके नॉर्मल डेटा टाइप जो है, स्केलर डेटा टाइप जो है, इंटीजर है या लॉन्ग इंट है, ठीक है, उसमें आप सच लॉन्ग इंटीजर 1000 डिजिट इंटीजर्स, 10,000 डिजिट इंटीजर्स आप रिप्रेजेंट नहीं कर सकोगे। तो फिर अल्टरनेट अप्रोच क्या है? अल्टरनेट अप्रोच है सॉफ्टवेयर अप्रोच। क्या कोई मुझे लिख के बताएगा कि सॉफ्टवेयर अप्रोच क्या होना चाहिए? मतलब हाउ आर वी गोइंग टू रिप्रेजेंट टू लॉन्ग इंटीजर्स ऑफ n डिजिट्स ईच, टू लॉन्ग इंटीजर्स ऑफ n डिजिट्स ईच, कैसे रिप्रेजेंट करोगे? इफ नॉट थ्रू ऑर्डर, यस, यूजिंग एन अरे। So I'm going to define 3 arrays: integer a of size n, integer array b of size n, integer array of size n. Don't think it's a C language, some general algorithm. तब यहां पर आप जब अरेज में करेंगे, तो आप जब आप ऐड करेंगे या टाइम को मल्टीप्लाई करेंगे, तो जनरली द टाइम कॉम्प्लेक्सिटी विल नॉट बी ऑर्डर ऑफ 1। क्यों? जब आप ऐड करोगे ना दो नंबर्स को, कैसे ऐड करोगे? आप एक फॉर लूप लेंगे। I will have to write like this: for I is equal to 1 to n, I will have to say like C of I is equal to A of I plus B of I with carry consideration. यहां पर मैं C बोल के लिख रहा हूं, this is B of I with carry consideration. Carry consideration. This will become my algorithm for adding two long integers whose digits are in an array. So time complexity for addition now become order of n. उसी तरह अगर आप मल्टीप्लाई करोगे ना दो इंटीजर्स, दो लॉन्ग इंटीजर्स रिप्रेजेंटेड इन एन अरे, द टाइम कॉम्प्लेक्सिटी विल बिकम ऑर्डर ऑफ एन स्क्वायर। दिस फॉर एडिशन, दिस इज फॉर मल्टीप्लीकेशन, दिस फॉर मल्टीप्लीकेशन। ठीक है? तो उसी फिर हम देखना चाहेंगे कि कैन वी मल्टीप्लाई देम यूजिंग डिवाइड एंड कॉन्कर मेथड। देन व्हाट विल बी द कॉम्प्लेक्सिटी? यस, वी कैन मल्टीप्लाई। फिर उसके बाद जैसा स्ट्रासेंस ने एक ऑप्टिमाइजेशन किया था, उसी तरह यहां पर और एक कंप्यूटर साइंटिस्ट है जिसका नाम है कराटसुबा, एनाटोली कराटसुबा। So we just say AK. So we have something called AK optimization. AK optimization के बाद और एक भी ऑप्टिमाइजेशन है, टू मैन कुक, वो आप देख सकते हो। तो मैं खाली एक प्रॉब्लम डेफिनेशन यहाँ पे आपको बता रहा हूँ कि दिस इज ऑल्सो ए प्रॉब्लम विच यू कैन स्टडी बेस्ड ऑन डिवाइड एंड कॉन्कर। इन एडिशन टू दैट देयर इज वन मोर प्रॉब्लम विच यू कैन स्टडी बेस्ड ऑन डिवाइड एंड कॉन्कर, एंड दैट इज कॉल्ड calculating number of inversions in an array. Number of inversions in an array you can calculate using the principle of divide and conquer. This is more or less using the philosophy of merge sort. Okay? Number of inversions in an array. So these are some of the additional problems which you can prepare for solving problems of divide and conquer. So like that you can prepare. And last thing which I would like you to do is master the master method, master theorem. Plus you also learn how to solve recurrences using recursion tree. That should be the ideal learning path for divide and conquer completion, recursion tree. आप ये दोनों भी master method से देख सकते हैं, right? Radix sort is not based on any of these. Radix sort is a non-comparison based sort, Vandana. Non-comparison based. It is not at all based on divide and conquer. ठीक है? Non-comparison based. ठीक है? अब before we close for today's session, let us see some basic questions. Please read this question. I am very sure, right? Please make sure you are able to work out this question. Come on. I'm not going to solve it. I'll just give the hints. For all these questions, you can solve. Come on, take up this question and tell me how are we going to solve this question, please. how to approach this, because I have seen many people going wrong with this question. At least I will discuss with you, if not solve fully. Any answers for this, or any approach you at least describe in your chat box? How should you solve? $240 is not correct, I think. Upadhyay, check it again. ऐसे क्वेश्चंस में थोड़े वेरिएशंस भी आ सकते हैं, so you can expect this type of problems in the exam. Yeah, Khadir, you're right. 512 is right. 768 is wrong. That's a mistake. Naveen Kumar. Saurav Shinde, 512. Can you just write in one line what should be the approach of solving this question? Approach बताइए, लिखिए कैसे करोगे? Akash Pai, Akash Paul. I don't have any idea about that. What you are asking? Good evening. Koi? Not comparison time. And log n is equal to 30. Okay. n log n टाइम कॉम्प्लेक्सिटी को लेकर वैल्यू पुट करेंगे, ठीक है? ओके, let us read the question and try to interpret it. Merge sort take 30 seconds to sort 64 elements. In worst case लीजिए, worst case time same है. What is the approximate number of elements that can be sorted in the worst case using merge sort in 6 minutes? 6 minutes is equal to how many seconds? 360 seconds. Some people do interesting activity. यहाँ पर एक बहुत इंटरेस्टिंग एक्टिविटी करते हैं स्टूडेंट्स. व्हेन आई सॉल्व दिस क्वेश्चन इन द क्लास, इंटरेस्टिंग एक्टिविटी इज 30 seconds you can sort 64 elements. 360 seconds, how many elements? Some people do like this. Is it correct? बताइए, is it correct? Is it the right approach? 360 seconds, how many elements? They do like this: 360 into 64 divided by 30. Whatever answer you are getting, sir, those many elements you can sort. Is it right? No, it is not right. It is wrong. Wrong because अगर आप इस तरीके से डायरेक्ट लीनियर अलजेब्रा के टाइप में कर लेंगे, then what is the role of merge sort? You can ask yourself, what is the role of merge sort here? If you do like this, then this should not be a gate question. What is the time complexity of merge sort? Come on, time complexity. Time complexity of merge sort is n into log n for sorting n elements. लेकिन यहां ये अंडरस्टैंड करना बहुत जरूरी है, ये जो n log n है, दिस इज इन यूनिट्स ऑफ व्हाट? ये जो टाइम है n log n, इट इज इन विच यूनिट्स ऑफ टाइम? दिस इज a priori time, this is asymptotic time. Asymptotic time. A priori based analysis पे means n log n units of time, it is independent of seconds. Am I right? It is independent of seconds. N log n is independent of seconds. So when I have 64 elements, to sort 64 elements, what is the independent units of time I need? 64 into log of 64 to base 2, which is nothing but 6 into 64 units. Correct? So logically 6 into 64 units is needed to sort 64 elements, which is equivalent to, on a particular machine, 30 seconds. Equivalent to 30 seconds, because when I run 64 elements, the time taken is 30 seconds. तो मतलब ये दोनों सेम है. This is a priori time, this is a posteriori time. That is the beauty of it. It is a posteriori. After running on the machine, ये time है आपका. तो ये basis पर आप क्या करोगे? 1 second is equivalent to maybe how many generic units, or 1 generic unit is equal to how many seconds? ये आप क्या calculate कर सकते हैं? 1 second correspond to how many? ठीक है? 1 second correspond to how much a priori time on that platform, on that machine. 1 second is equal to how many a priori units of time, that you can calculate. Yes, 30 divided by 64 into 6 units 1 second. तो वही मशीन पे 360 सेकंड जो n एलिमेंट्स को लग रहा टाइम सॉर्ट करने के लिए, n एलिमेंट्स को लग रहा टाइम, तो 360 सेकंड यूनिट्स ऑफ टाइम एक्चुअली करस्पॉन्ड टू how many generic units that you have to find. Are you getting my point? I'm not solving it fully, I'm giving you hints, but ultimately it is leading to the full solution. Check it. So 1 second के generic units कितना है आप निकाल लिए, as Khadir has said, 30 divided by 64 into 6 seconds, 1 unit correspond to that, 1 second correspond to 360 seconds correspond to how many units? 360 seconds if I consider is used for sorting n element, 360 seconds. So 360 second correspond to how many generic units? So जो भी आपका value आएगी x, let us say x, right? So this x units of time is taken, generic units of time is taken to sort n elements, लेकिन sort n elements करने के लिए आपका time कितना है? तो ये तो एक numerical value है, right? Numerical value आ जाएगी. So this numerical value you have to equate it to n log n, because merge sort say time complexity to sort n elements is n log n. So this unit which you said you have to derive, equate it to n log n, find the value of n, you will get the value of n is equal to 512. That is the correct approach of solving. Yes, 4608 is correct. You have to equate 4608 to n log n and find the value of n. Using your principles of basic maths, you get the answer 2 power 9, 512, correct. 512 answer. ये है approach, correct approach. Some basic questions, you check it. This was the previous gate question. This is a recurrence that arises in one of the problems, like for example, in merge sort. So I here just wanted to tell you one aspect here, that such recurrences, I'm not solving it, I just wanted to tell you, when you are given such asymmetric recurrences, asymmetric in the sense that the size of the subproblems are different, one is n by 2, the other is 2n by 5, such recurrences can be very effectively and efficiently solved using recursion tree. Using recursion tree method. So I would advise you use recursion tree method to solve, and such equations most of the time evaluate to n log n. So the answer for this is straight away theta of n log n. Recursion tree method, you can try and solve it. Usi tarah, this we have seen yesterday, I believe, right? 2t root n in the form of algorithm. Now it is given in the form of recursion. So when you solve using either master method or using back substitution, this theta of log n, we have seen that already in the last class yesterday. I think last year this question was asked based on master method. You can check based on master method. This divide and conquer recurrence, t of n is equal to atn by b plus f of n. So therefore, if f of n is n log n, this is no way a case. F of n is n by n log n, this is also not a case. The master method is based on 3 cases: case 1, case 2, case 3. Case 1 is based on big O, case 2 is based on theta, case 3 is based on omega. So this is basically answer C. F of n is order of n power log a to base b minus epsilon. For some epsilon greater than 0, then this is exactly case 1. This is exactly case 1. So some master method cases can also be asked as a multiple choice question. That is what I am trying to say. So that is the correct answer for this. Okay? So just last, I think we will take up this question. Can you match the pairs? Matching pair question. Matching pair. Match the pairs and tell me what is the correct answer. C. Okay. Very fast. Towers of Hanoi. Exponential complexity. The equation for towers of Hanoi is 2tn minus 1 plus constant. Moving from 2 towers on to 2 towers plus constant. On expansion is theta of this. Binary search given sorted numbers n log n, right? And heap sort n log n. And addition of 2 matrices, we earlier said, is theta of n square. That's it. So that is the answer for it. So sometimes you can expect questions in this also. So for that, you basically can try writing the recurrences and their complexities directly in the form of short notes. Make short notes for all the problems of divide and conquer, right? Make short notes for all the divide and conquer problems in terms of the recurrences, in terms of time complexity, in terms of space complexity. Okay? So this is what I basically wanted to discuss with regard to divide and conquer. Next lecture we will start with greedy method. Okay. Boy, you are asking to 2024 ka batch, which is going to start from 21st December batch B. I don't know, please, you have to, I don't have absolutely any knowledge with regard to start and end time of any batch. You can check the PW app for that. I'm not knowledgeable with regard to it. Okay. Thank you very much. Take care. Good night. Right. Enjoy problem solving.